This is the lessons for 12-6 day 1 and 12-6 day 2. Yes, we're going back to chapter 12. We sort of skipped over the last 2/3 of chapter 12 just because we were hoping to do it in school, but unfortunately we can't. If you have friends in Mrs. Andrews' algebra class, they are not doing this. We were about a week and a half ahead of them when school ended. So anyway, what we're doing in chapter 12 is something called simplifying square roots. Another name for a square root is, you're going to hear me say the word radical a lot. Radical is another name for square root. So instead of saying the square root of 25, you could say radical 25 or radical 30. If you type the square root into the calculator, first of all, where is the square root button on the calculator? You'll see the square root button right here above the x squared. Notice that it is a blue function on my calculator, so you'd have to hit second and then your square root button. So if we wanted to do that, if we wanted the square root of 25, we would hit second and x squared, which is your square root. Notice the square root, the little check mark comes up. And then, for example, the square root of 25, you would type in the 25 next and hit equals or enter, and it gives you 5. But the calculator sort of lies. Every square root has both a positive and negative answer. So you're going to see this symbol a lot in the notes and in your work. It is the plus or minus symbol. Because the square root of 25 is both 5 and negative 5. Because 5 times 5 is 25, but also negative 5 times negative 5 is 25. If we type in the square root of 30 into the calculator, you're going to get a big long decimal answer, 5.4772257, blah, 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 blah. You're going to round it to the nearest tenth, so we would just say plus or minus 5.5. So there's some perfect squares that we need to know. These are very important to memorize because they'll help you out. The square root of 1 is 1. It's plus or minus 1. The square root of 4, what times what is 4? Well, it's 2, so positive 2 and negative 2, so plus or minus 2. Square root of 9 is 3, plus or minus 3. The square root of 16 is plus or minus 4. Square root of 25 is 5, and so on and so forth. These are all very good ones to memorize, especially 400, 225. They use 100s a lot, and all these little ones. These ones, not so much, but these little ones, very, very important to memorize. Square rooting is the opposite of squaring a number. So what you're going to have to do is you're going to have to simplify a radical. You're going to have to put it in simplest radical form. Well, what does that mean to put it in simplest radical form? Well, what we're looking at is what times what is 75. What we want are perfect squares of 75. So these numbers that are in the black, which ones of those numbers go into 75? So what times what is 75? Well, I like to write right underneath it what it is. What times what is 75? Well, 25 times 3 is 75. What you're going to do is that you're actually going to take the square root of 25. I like to sort of put an x on it and bring out the 5, because the square root of 25 is 5. So I'm going to cross off the 25, I'm going to bring out the 5. It ends up being, in simplest radical form, 5 radical 3. This really means 5 times radical 3. If you actually type that into the calculator, and if you type in the square root of 75, you're going to get your answer. If you type in 5 square root 3, or 5 times the square root of 3, you're going to get the same answer. It equals the same answer in decimal form. But now remember, it's not just 5 radical 3, it's plus or minus 5 radical 3. The square root of 200, and that's all that we're doing is simplifying radicals, so if you didn't understand that one, just hold on. The square root of 200. Well, what times what is 200? Well, I know that 100 times 2 is 200. 100 being a perfect square. 100 is really 10 times 10, so cross off the 100, bring out the 10. So that becomes 10 radical 2, and it's really plus or minus 10 radical 2. 147. Now you might be thinking, what the heck is what times what is 147? Well, try some perfect squares. What actually it is 49 times 3. 49 being a perfect square. So cross off the 49, bring out the 7, so it becomes 7 radical 3, plus or minus 7 radical 3. 245. What times what is 245? Well, that's another hard one. It's actually 49 times 5, 49 being a perfect square. Cross off the 49, bring out the 7, so it becomes 7 radical 5, plus or minus 7 radical 5. This is all that you're doing in the lesson, so we're going to do some more. Does every square root simplify? No, it does not. You cannot take the square root of a negative number. If you actually type that into the calculator, you're going to get an error on the calculator, because there is no such thing as the square root of a negative number. It's actually an imaginary number that you'll get into in 10th and 11th grade. The square root of 30 can't be simplified. Yes, 6 times 5 is 30, but neither one of those are perfect squares, so it doesn't get us anywhere. 10 times 3 is 30, but again, 10 and 3 are not perfect squares, they can't be simplified. 15 and 2. Yes, 15 times 2 is 30, but they're not using perfect squares, so that doesn't get us anywhere. 30 can't be simplified. What is the square root of 30 or radical 30 in simplest form? It's just radical 30. That one can't be simplified at all. 101, for example. You can't get anything that is 101. What times what is 101 besides 101 times 1? It is what's called a prime number. Prime numbers can't be simplified, so in simplest radical form, it's just radical 101, or the square root of 101. So why do I have the square root of 72 twice? Well, you can do it, some of these you can do in multiple ways. What times what is 72? Well, I could do it this way, using 36 and 2. I could also do it this way, using 9 and 8. I'm going to show you two different ways to do this one. You'll get the same answer in the end. What times what is 36? Well, 36 is a perfect square. Cross off the 36, bring out the 6. So this becomes 6 radical 2, plus or minus 6 radical 2. 9 times 8 is also 72. Well, 9 is a perfect square. Cross off the 9, bring out the 3. So now I have 3 radical 8. But 8 can be simplified even farther. 8 is really 4 times 2. 4 is a perfect square. Cross off the 4, bring out the 2. When we bring it out, we're actually going to multiply these together. So we have 2 times 3 on the outside, which is 6, and then we're just left with the 2 on the inside. Notice that we got 6 radical 2 for both of them. Sometimes, the bigger the perfect square you use, the less steps you'll have. If you use smaller perfect squares like 9 and 4, you'll have to do more steps. So the bigger the perfect squares, the less steps. But again, you get the same answer in the end. Let me show you another one with 108. What times what is 108? You could use 36 times 3, but you could also use 4 times 27. Both of those equal 108. 36 is a perfect square. Cross off the 36, bring out the 6, so you end up with 6 radical 3, plus or minus 6 radical 3. If you do it this way, 4 is a perfect square. Cross off the 4, bring out the 2, so you have 2 radical 27. Well, 27 can be simplified more. 27 is really 9 times 3, 9 being a perfect square. Cross off the 9, bring out the 3. When we bring it out, we have to multiply these together. So 3 times 2 is 6. Again, we get plus or minus 6 radical 3, no matter which way you did it. We're going to do a couple more examples. Sometimes you'll start off with numbers outside. Again, anytime we bring things out and we have multiple numbers outside, we're going to multiply those together. So starting off with 4 radical 72. If we have to put this in simplest radical form, 72 is really 36 times 2. 36 being a perfect square, cross off the 36, bring out the 6. So 6 times 4 is 24 on the outside. All that we're left with on the inside is a 2. So we have 24 radical 2. What times what is 60? Well, 60 is really 15 times 4. 4 being a perfect square. Cross off the 4, bring out the 2. 2 times 12 on the outside is 24. All that we have left on the inside is 15. So 15 can't be broken down anymore. Yes, 5 times 3 is 15, but neither one is a perfect square. So we're just going to leave it plus or minus 24 radical 15. If we do 28 radical 12, 12 is a perfect square. Or not, 12 isn't a perfect square, but 4 times 3 is 12, with 4 being a perfect square. Cross off the 4, bring out the 2. 2 times 28 is 56, so we end up with 56 radical 3, plus or minus. 24, what times what is 24? Well, 4 times 6 is 24. Yes, you could do 8 times 3 and break down the 8 even farther, but I want to go right to the perfect squares. Cross off the 4, bring out the 2. 2 times 15 is 30, so we end up with 30 radical 6, plus or minus 30 radical 6. And that's how we do 12-6 day 1. There are more examples in your notes, in the hard copy of notes. Moving on to 12-6 day 2. Now we're going to take that knowledge and we're going to solve quadratic equations. Solve by taking the square root of both sides. Just like in solving a normal equation, whatever you do to one side of the equal sign, you have to do to the other side of the equal sign. This is a good strategy to use when there's no bx term, when there's no b term there. Take the square root of both sides. Make sure to use the plus or minus symbol. Read the directions, because sometimes they're going to have you put your final answer in simplest radical form, which is what we just did in the last lesson. Other times they're going to actually have you just find the decimal form. And sometimes they'll have you round to the nearest tenth, most likely. So if we have this equation, n squared equals 25, the opposite of squaring a number is to take the square root of a number. The square root of this, the square root and square root. Same thing here, square root, square root. Same thing here, square root, square root. We just want to take the square root of both sides to get rid of that square. The square root of n squared is just n. Well, the square root of 25 happens to be a perfect square. So that is plus or minus 5. In the middle one, taking the square root of x squared, that's just x. The square root of 72. If they asked you to do it in simplest radical form, we would have to do 36 times 2. 36 being a perfect square, cross off the 36, bring out the 6. So this becomes plus or minus 6 radical 2. That's in simplest radical form. As a decimal, all that you would have to do, you don't have to do this part at all if they ask you it as a decimal. In decimal form, we're taking the square root of x squared, which is x, the square root of 72. Just type it into your calculator. If you type it into your calculator, let's say the directions said to round it to the nearest tenth, you would get x equals plus or minus 8.5. For n squared equals 41, take the square root. In simplest radical form, 41 can't be simplified. Nothing times nothing is 41. 41 is a prime number. So in simplest radical form, it'd just be n equals radical 41, plus or minus radical 41. If they asked you to do it in decimal form, rounding to the nearest tenth, you would just type in the square root of 41, and that happens to be plus or minus 6.4. So again, pay attention whether directions say simplest radical form or rounding to the nearest tenth. In this one, when you do it, both of them would be the same. They'd both be plus or minus 5, simplest radical form and decimal form. So a little bit more complicated ones. The first thing that we want to do is take the square root of both sides, and you're really going to solve it twice. Once using the plus sign and once using the minus sign. So the opposite of squaring a number is to take the square root. So we want to take the square root of both sides. That's the first step that we want to do. When you take the square root of this one, the parentheses will disappear and the squared will disappear. So all we're left with is m minus 2. But on the other side, the square root of 25. The square root of 25 is plus or minus 5. Well, here's where it gets a little bit weird. What we want to do from here is break it into two separate problems. After you take the square root and write down whatever that is with your plus or minus. You want to break it into two problems because we want to find the one with the positive 5 and the one with the negative 5. So we really have two separate problems here. We have n minus 2 equals positive 5, and we have n minus 2 equals negative 5. Because we had this plus or minus, we have to do two separate equations. Now you're just solving two separate problems. We're going to sort of split it right down the middle. It's just solving the one-step equation, plus 2 and plus 2, m equals 7. That's one of your answers. Plus 2 and plus 2 to get rid of the minus 2. So we end up with m equals negative 3. So your two answers are 7 and negative 3. A little bit weird, but that's what you have to do. Because of the plus or minus, you're really solving two questions at the same time, and then in order to get to your final answer, you got to split it into two. So let's do another one just like that. To get rid of that squared, we need to take the square root and square root. When you take the square root, you end up getting rid of your parentheses and your squared. So this becomes 2n plus 3 equals plus or minus 7. Again, once you do that, you want to split it into two. Because we have 2n plus 3 equals 7, and 2n plus 3 equals negative 7. We have a 7 and a negative 7. So now you're just going to solve those two-step equations. When we solve those two-step equations, minus 3 minus 3. So 2n equals 4, divide by 2's, n equals 2. In this one, minus 3 minus 3. So we have 2n equals negative 10. Divide by 2's, n equals negative 5. So our two answers are positive 2 and negative 5. We're going to skip these next two examples. If you want to see these two done, take a look at the hard copy of notes. Taking a look at this one, I want to do one more because this one's a little bit weird. When you take the square root of both sides to get rid of that parentheses and the squared, this becomes x plus 5 equals radical 50. Now, radical 50 can be simplified. Radical 50 is really 25. 50 is really 25 times 2. Cross off the 25, bring out the 5. So we really have x plus 5 equals plus or minus 5 radical 2 in simplest radical form. If they ask you in decimal form, you don't need to convert it, just make it into a decimal. So now when we go to solve it, this is the weird part. We need to split it into two, just like we did before. So we have x plus 5 equals 5 radical 2. And we have x plus 5 equals negative 5 radical 2. Again, that plus or minus, we split it into 2. So solving this one, minus 5, minus 5, minus 5, minus 5. This is where it gets tricky. These cancel out, but this is one thing that we didn't learn about yet, is you can't, if we're leaving it in simplest radical form, you can't do 5 radical 2 minus 5. 5 radical 2 minus 5 in simplest radical form is just 5 radical 2 minus 5. You can't do anything to it. You leave your final answer just like that in simplest radical form. For this one, it would end up being x equals negative 5 radical 2 minus 5. Again, that's in simplest radical form. If it asks you for it in decimal form, you could either just type that in, or we could have changed this to a decimal right away. If we did that, we would have ended up with x equals 2.1, and we would have ended up with x equals negative 12.1. Again, I'm not going to do this last one just to save a little time, but if you want to look at the next one, take a look at the hard copy of notes. Please pay attention whether they ask you to put it in simplest radical form or as a decimal rounded to the nearest tenth.